A very good morning to all of you.
Live is started.
1 minute, sir. 1 minute.
Who are missing, they will take the live or the AICTE portal or they will get live.
I'll welcome all of you in the third session of Integration of AI and ML in Electromobility System. I'll welcome our chief guest, Dr. Priyanka Singh, Assistant Professor, Department of Computer Science and Engineering at IIIT RAICHUR. Ma'am has worked as an assistant professor at SRM University and also at VIT Bhopal. Ma'am has completed her doctorate from Motilal Nehru National Institute of Technology, Allahabad, with soft computing and optimization as a research area. She has completed her MTech from IIIT Allahabad with machine learning. She has expertise in machine learning, optimization, neural network, and hybrid intelligence system. She has published almost more than 10 plus SCI index paper and contributed in different books and international conferences. Today, ma'am will be dealing with application of AI and ML in electric mobility system. Thank you, ma'am. Now I would like to call Professor Amrin Masta, Head Department of Electrical Engineering, to welcome ma'am with a bouquet as a essence of respect and love.
Check the sound.
So thank you, first of all, very thank you to all of you and asking me maybe at the last minute, but I'm very happy that I'm here because this is going to be my first presentation going to be the offline for some program like this, and I'm very fortunate and happy to be there. And I thank HOD sir and other faculty members and the candidates in the participants here for participating in this FDP program. And I hope the whole FDP for the participant is going to be very good. And the content, the relevancy, whatever is given to them, they will be definitely, that is going to be very definitely good for them or helpful in the future in both the academic as well as for the research. So I would like to now continue with my topic, the presentation for today, which is the foundation and the application of AI and ML in the electric mobility. Voices, please. So I would like to first start with the topic, fundamentals of AI and machine learning, because you see whatever the topic we are going with, electric vehicles, electric mobility system and all, we need to first understand that how AI is going to be So how AI is going to be introduced or how AI is going to be used in this particular application, which is EVs, or you can say electric mobility system. So there are so many things, right? You might have already gone through the previous session that what is AI. So I'm not going to go into the details or spend too much time on the AI. But I'm going to discuss definitely that how AI is going to be helpful for our application, right? So AI is something which is basically getting introduced in our research, in our industry, in our teaching for different purposes. So what we want is the systems and whatever the systems or whatever the applications we are creating, we want that they should be able to think, behave, or reason the way we are doing it, the way humans are doing it. So we want the systems to do the same. So how they can do it? By making them intelligent, but they can't be intelligent like us, so we need to artificially make them intelligent, right? So the way we are doing it, when we are making those systems, models, making them intelligent, but artificially, we call such system as an AI-based models or AI-based system. So what is AI? We can start with an example like autonomous driving system. We have seen there are so many different brands who are proposing different types of the car. They are going through this autonomous driving system, right? One of them was the recent proposed by Tesla, right? So you see the driver is there, but even though without a driver it is working now, we are trying to get a very good precision in the terms of you can say driving, not having any accident and all. But yes, when it comes to the autonomous, we want that everything, including the steering, acceleration, brake, everything what has to be done by the driver is now done by the AI, which is helping that system or helping that car to get into the application such that the human does not have to involve, the person can enjoy it, but everything is done by the AI, right? So this is just a diagram to represent that how this autonomous driving system works, what are the different things which are there. So there has to be an environment action, and then there has to be an actor who should respond on the basis of the things which is being perceived from the environment. So the AI has been involved from the several years, right? It's not that AI has been just come up 10 years ago, but it was there. But when it was you can say when it was proposed, so this is the timeline to see that when it came into the research or it came into the knowledge that yeah, AI should be there. So nowadays we have already gone through this thing, generative AI and the foundation of machine learning. This was a basic era of the machine learning where we were talking about neural network, support vector machine, and a little bit of the deep learning model. So there are different techniques of AI which we go through: the supervised learning, unsupervised learning, reinforcement learning, and those also we go with the optimization approach. Then we have fuzzy logic. These are all the techniques which are used in the AI to make our system intelligent, or to make our model intelligent. But why we are going to talk about the AI for the faculties, how it is going to help in the FD. So if you see for the faculties, if you are introducing subjects like subjects like AI, like artificial intelligence, or subjects like computational intelligence, or maybe soft computing, hybrid computing, all these are all the courses which are somehow involving the intelligence of the system. So these should be involved in our curriculum, because nowadays the industry is also looking for the students or for the people who are good at AI or who can work on the research on the AI. Even there is more chances of going to the interdisciplinary research, right? And the people who are working with electrical, they can work with the computer science for going with the AI. The people who are working in the chemical, even in the mechanical, they can use the optimization method, right? So interdisciplinary research is there. We can have lots of funding, and based on the proposals which are written and the publication, we can have the patents, and even it is aligning somehow with the NEP 2020. So coming back to the topics of the AI, we have three different types of AI: narrow AI, general AI, and the other one is super AI. The remaining two, the general AI and the super AI, they are not existing for now. We have mostly the narrow AI. We are in the era of the narrow AI, or we say narrow artificial intelligence. So what does it mean? Let's take an example of, let's say, Siri, Alexa, or any Google Assistant, or let's say Google Assistant. So what they do is, when the question is asked, based on that they are giving the response. They are actually narrow. They are working only in a particular area. They are giving a response in a particular area. For example, when we are having any voice assistant in our car, so if we ask to just play the music, so it is only able to play the music, because that particular assistant has been created only for that particular application. So it is narrow AI, saying that it is AI, but it is only specific to some of the tasks. When it comes to the general, it says that okay, it can think like human, the way human is doing every task. So we are expecting the AI to do the same thing. But such type of AI we are not having. The other is super AI. So super AI is a hypothetical AI which says that the intelligence should go beyond the intelligence of the human. Okay? So these two are not currently existing, but we are in the era of right now narrow AI. So I already gave you an example of the Tesla, right? For example, when we want to control the cabin temperature, we want to play the music, when we want to navigate from one place to another, so we have assistant there in the Tesla, right? But when we want that there should be something new comes up, not related to the, let's say, playing the music or moving from one location to another. If I say just call somebody, and if that feature is not available in the Tesla, let's say, so it cannot do it. For example, when I ask you to make a call, it cannot do it until I open it. So that intelligence is not there to unlock it on its own, right? So that is the example of a weak or a narrow AI. Now coming to the why, since we are talking about the AI, artificial intelligence, it cannot come on its own. So we need to go into the algorithms, or you can say we need to talk about how the intelligence can be brought. So intelligence comes up with the different things, which includes the machine learning. Basically, how my machine is going to learn. So when I'm saying it's a system or a model, all these are nothing. It's just a machine whom I want to train, right? So what is the machine learning? So it's just you can say it's a subset of the AI. Through the machine learning, we are able to train our systems, right? So it's just a branch or a subset of the AI which tries to make the decision or make a reasoning or give a response very similar to the human learning, right? So learning from the experience is the best way that machine learning algorithms do. So there are different types. This flow diagram is nothing just representing that how machine learning works. So it first needs to take the data, then the model will learn. Once the model is trained, then it is going to test. Right? So based on that, the prediction or the classification will happen. So this is a very simple example of electric vehicle where we are using one of the machine learning model, which is neural network. I hope everybody is aware of the term neural network. So here in this example, what we are doing is we are taking the data from the sensors which is available in the car. Right? So I am assuming, since I am not from the electrical background, I am not going to take too much data, or I am not going to talk about too much of the data. So the simple ones I am talking. So let's say I am taking the data from the battery, that how much consumption has already been done, or what is the lifetime of the battery. All those information can come. From the motors which is there, some information can come. Vision, we need to have cameras and the sensor, they are going to collect the information from there. Now all these are going to act as an input data, right? Now the input is going to get to the any of the model. Here we are assuming about the neural network. So the neural network is taking all those input parameters. Based on that, it is going to make some conclusion, or it can say inferences, right? So based on that, whatever the prediction comes, so it could be helpful for the different reasons or different applications. So one of the output could be energy management. Like from the output, we can find out that how we can plan or how we can manage the energy in our car. How the driver, from this data itself, we can find out or we can justify the way the driver is moving, or whether the pattern is correct or not, whether the driver is okay or not. Dizziness is there. So there are different applications which can be brought. Later on, there is another thing which is object detection. Since the car is moving, there are several objects which will be coming in the path. So how to detect, right? So for that also we are going to have images which will come from the vision topic, right? So there are different feasible applications in this particular example or particular diagram you can say. And later on, whatever the result comes, it can be used as a reinforcement learning. And the same can be used again to train the model and adjust whatever the error or inaccuracies are. Now, since I said the machine learning is of different types, so one of them is supervised, unsupervised, then second, and third one is reinforcement, then nowadays we have a semi-supervised learning. So I hope everybody is aware of the supervised learning. So we can have both, the classification as well as prediction. Two types of problem can be there. Classification and regression. So what does the regression say? Let's say I have to predict something, that when the battery is going to be dead, or what is the feasible time that, what is the state of the battery, or we want to find it out whether what is the probability that the person is going to be dizzy while this person has been driving for the long period of time. So if we want to predict something which is going to be something real, right, then we are going to go with a regression model. So in machine learning, or you can say machine learning algorithms, we have two classes of algorithms. One is for the classification and one is for the regression. So the regression is the one which is always predicting something, saying that I'm going to generate the output which is going to be some discrete one. And in the case of the classification, we classify whether it will work or not. It could be, for example, yes or no, or it could be a specific class, class A, class B. It could be multi-class also, right? So here we have taken some example like fault classification in the charging station. So there are several charging stations which are there for the EVs. Now we have to classify whether this EV is particularly faulty or not, right? So fault detection has to occur. So the classification is now there. So we can use the unsupervised learning algorithm. So we will discuss some of them, like what algorithms are there. Then we can have at the state of the health prediction. We need to predict what is the state of health of the particular battery, in which phase it is, right? So that also, if we want, we can do with a regression model. Now the next is unsupervised learning. In the unsupervised learning, what we do is, we don't know what is, we have a data, but there is nothing as output. In the case of previous algorithm, like supervised, we do have an input, we do have output. So we train our model on the basis of input and output. Okay. Now once it is trained, we test it. But when it comes to the unsupervised learning, we only have the input, we are not having output. So you see, it's I can give you the example of pedagogy of a class, right? When we say in the class that make a group of 5, right? I want to have only 5 groups in the class. So you're not saying what, on what basis they have to create a group. The student can make on any basis, maybe on the basis of their region or on the basis of their friendship, right? So we are not telling on what basis, so that now can be considered as an unsupervised learning. So similarly here, like if we want to find what is the charging behavior, charging behavior clustering for the infrastructure planning. Let's say in the future we want to plan the infrastructure based on what is the charging behavior for the particular installed charging stations, right? So in that case, the clustering approach can be applied, which is a part of the unsupervised learning. Similarly, we can have a reinforcement learning. So reinforcement learning is something which is based on the concept of reward and punishment. If the machine is able to learn properly, then the reward is given. If it is not able to learn properly, then punishment will be given. So based on the punishment and the reward, the machine understands I am taking a correct step or an incorrect step, right? So we can have example like optimizing the regenerative rate. Like for the, let's say we have a system, we have a car, right? Initially it is not able to it is not able to apply a good brake, right? So after several mistakes, like after several learning, maybe after punishment and the reward, it will understand that whatever the step I am taking, it is wrong. So after several iterations or several steps, it will reconsider it and it will start making a correct. It will start putting a correct pressure on the brake and all. Okay. So this is just an example. I hope everybody is aware. Just a diagram to show that what are the components which we have in the electric vehicle, and we can collect the data from these components along with the other components too. Now coming to the algorithm, as I said, we have different types of the algorithms: supervised, unsupervised, and reinforcement. So these are few algorithms which are used nowadays for the electric mobility applications. So one of the basic one is linear regression. So linear regression is a supervised learning algorithm. It's a type of a equation. It follows a mathematical equation very similar to your line of equation like y is equals to mx plus c. Right? So it says that we need to have some simple data, just provide the data into it, and it will generate the model is going to generate a curve fitting equation based on our input data, and later on we test on that. So it's a very old model right now. Now later on we have some other models like decision tree and random forest, which is used for the clustering. Unsupervised learning. Okay. So we can have a vehicle, like the previous example itself is there, like we have to identify unusual clusters. Now we are going to create several clusters based on the behavior of the battery, based on behavior of the vehicle. So which will be done on the basis of the data. So whatever the data we are collecting, that is temperature and the fluid level, based on that we will decide whether there is an anomaly in the battery or not, whether the battery is working properly or not. So we are saying yes or no. So now it comes to the classification method. Okay. Then there are different types. I'm going to talk more about the neural network and the deep learning. So a neural network starts with the multi-layer perceptron, right? And later on in the deep learning, we continue with the advanced version of the neural network like CNN, STM, RNN and all. So we are going to discuss through the details of all these algorithms. So this is an example of the supervised learning. Just to show that, let's say that we are taking the two data, the charge per cycle, charge cycle, how much time it is taking to charge a particular EV, let's say, and what is the maximum temperature. Based on that, we are finding what is the state of the health of the battery. So you see, these are the input data. We have considered 4 samples. Now, based on that, we have taken a machine learning algorithm. So machine learning algorithm could be anything. Let's say we are taking a regression model. Now, this regression model is going to train on this data, and later on we have a trained SOH predictor because it is created SOH, the state of health of the battery. Now we have a trained model. Once we are training our model, after that we have to simply test it, right? So in order to test it, we are going to provide a new EV data, which will be published on again. We will again provide a new data, unseen data, which will be having charge cycle and the maximum temperature, which is not going to be from there. So based on that, it will predict some output. So let's say it is predicted 85.7%. So this is the SOH of that battery when the charge cycle is whatever the new data provided and what is the maximum temperature which has been given, right? So we are predicting the future battery, the future of the battery capacity based on the historical data. So now this is acting as a historical data. When it comes to the when we are saying historical data, mostly in the case of prediction or regression model, we use such data. We need to have, when we want to find out something, when we want to predict, right, we need to see the history of the data. We need to have enough data so that it could be given to our model, and then it could predict or it could suggest that this is the possibility that will happen in the future. Now, when we are going to use a machine learning algorithm, it becomes very, it's very important to understand that when we are applying any algorithm, we should do the data pre-process, right? So there are different stages of pre-processing, but I'm not going to go into the detail of all, but there are few which is very important with respect to the EV, right? So first thing is when it comes to the data, we need to see whether there are some data which is missing or not, right? For example, it might be that the battery is off for some time, maybe some of the component is not working. So for that particular component, we won't be having data for some time, right? So how to handle such data? So few approaches are there, like binning method, going through the averaging, or we can use RMR model in order to fill the gaps, fill the data which is not. Then we can have some inaccurate data too, like when the device or particular sensor becomes faulty, so we can start getting inaccurate data, right? So we need to see that whether there is an inaccurate data or there is an outlier there, how we are going to handle it. So all those things comes into the data pre-processing. So nowadays what we see is most of the people, they get the data, they start putting it directly onto the machine learning. But we need to follow the approach that is data pre-processing, that has to be done. So once we pre-process the data, there is another thing which is feature engineering, which says that there are some parameters or some data which we should not directly use it, but we should change it, or we should bring, or we should create some other data from the existing data. For example, you see, creating a degradation rate feature. If I have some data and I want to create a degradation rate, right? That how the battery is degrading, what is the rate of degradation of the battery? So we need to have some data, some raw data. For example, if I am having charge cycle number and the maximum capacity, these two are given to us. Now, based on that, we can create this feature which is degradation rate. We can calculate it, which could be initial capacity minus current capacity divided by the charge cycle. So based on that, we are getting degradation rate. Now, this feature is very, very important in the terms of research. When I am calculating the state of the health of the battery, this feature becomes important. But I cannot get it. So what we did is we have prepared this data. So preparation of some new data from the available data is called feature engineering. Now, there is another term which is normalization or scalability. When we are having different types of the data, all the different data have a different range too, right? So some data can have a range of 4,000 to 5,000 or 4,000 to 10,000. Another data, let's say temperature, can range from 0 to 100 degrees, right? So for some data, the range is very high. For some data, the range is something else. Or maybe for some, there could be negative range also. So how we are going to balance it? Right? So we do need to normalize it. So while normalization or scaling, what we do is, whatever the data we are having, we normalize all of them into the same range. And most of the time, we keep it within the range of 0 to 1 or maybe -1 to 1. So few common approaches are there. Like here in certain score, we have another like min-max composition, or we say min-max normalization approach is also there, which is used to normalize the data before we pass it to the neural network. Oh, sorry, before we pass it to the edge machine learning algorithm. But along with these models, whatever we have, we need to understand there are some evaluation matrices we also need to consider, right? So I cannot just, I am not very into this topic, but there are few things related to the prediction and the classification matrices which can be used. For example, in the case of regression, we do calculate what is the root mean square error, which is RMSE, then MAE, which is mean absolute error. These two are mostly used in order to find out what is the accuracy of the model. When we are when we are preparing any model, later on we are going to test it. So during the test, how will I say this model is good or bad, right? So I need to have some metric, performance metric. So when we are predicting, we go with the RMSE, MAE, MSE, or average error. When we are doing the classification, whether it is faulty or not, whether the battery has is dead or not, right? So when we are going with the classification, how will I say my model is good or bad? So now in the case of classification, we have precision, recall, F1 score, as well as accuracy is also there, right? So these are the few of the evaluation matrices which are used. So this is just a question. This is called as a confusion matrix, which is for the classification, which says that we can calculate the PR as a precision, recall, and this is classification accuracy, and this is F1 score. So we can calculate the precision, recall, and all these on the basis of these four terms: true positive, false negative, and true negative. So this was the basic of AI. Now how the AI can be used in the electric mobility, now what are the different challenges and what are the different opportunities. So these are the different areas where AI can be used, like computer vision for autonomy. When we are having car, let's say, so we can use the different cameras at different places, so which will act as a computer vision, right? For charging optimization, when the EVs are there, whatever the charging stations we are having, how we can optimize all those charging stations, how we can find it out at which place the charging stations has to be placed. Drive cycle prediction, like how much time the particular EV has been, let's say, particular EV has been driven for, what is the maximum time it took, or how much is the charging time based on the total duration, the total distance it has covered, right? EV motor control, intelligent BMS, battery management system, AI in the smart grid, and this vehicle to grid. So these are the different places where AI can be used, but I'm not going to go into all of this. Some of this we will see. But when we are talking about this, there are some challenges too, right? What are the different possible challenges? The first important challenge is the data, right? Nowadays, you see, we are talking about the EVs, but we see very maybe 2 or 3 out of 100 EVs, right? So we have very less number of vehicles, EV vehicles. So because of that, we have a limited data also. So limited real world EV data set is very one of the problem. Along with that, we have whatever the data even we are getting, they are going to be noisy, missing data, noisy data, or incomplete data we are getting, right? So this is another problem. Along with that, there is a privacy concern related to this data, because when we are asking the data from the different brands or different make of the vehicles, they are not able to provide the data because of the privacy concern, because they are also holding the data of the customer, which is personal to them, right? Personal to the customer, so they cannot be shared. So because of those concerns, the data related challenges is there. Another is computation and model challenges. Since we see that we need to have a real-time data which should be collected from the EVs, right? Now we have a real-time data, but the hardware which is available in the EV, they are not having a very good combination. So that's why we are not able to fetch the real-time data of this product. Another is the balanced accuracy with the battery consumption. Balancing accuracy with the battery consumption. Whatever the batteries we are having in the EVs or any electric mobile devices, in those cases, whatever the battery we are having, we are not getting a very accurate battery users also. So this is another challenge. Along with that, the model transferring what is there inside and what are the safety concerns, all those are not given to us. Then system integration challenges. This is another important, since we are having the components from the different cases, like integrating the AI model with the BMS. We are using the same AI model for the different companies, for the battery management, for the motor controller. So it's not possible to integrate all those things together with the AI. Along with that, cyber security challenges is also there, right? Now coming to the EV infrastructure challenge, we don't have a very widespread fast charging stations. We have a limited number of the stations right now. So that's why we are getting a less number of the data also. Along with that, grid instability, this is the one, a very important one. Grid instability during the peak EV demand. Since we are having a limited number of the EV charging stations, so where to whichever the transformer it is connected, on that particular transformer, the load is going to be very high. When the number of the EV vehicles are getting charged for the particular time, the load is very high, then the load on the transformer is also going to be very high for that particular time. So finding a peak time, along with that the load on the transformer is also becoming a very, becoming an issue for them, right? So making a grid, whole grid, making it this whole situation makes the whole grid unstable. So this is another concern. Along with that, the concern is related to the data, so that's why it is regulatively and ethical challenge. Now, what are the different opportunities that we have, right? We saw there are challenges, but we do have the opportunities, like smart and self-learning battery system. Whatever the battery system, battery management system when I'm saying, so in that case, we can make those battery management system as self-learning battery systems, and they can be smart also. So when we say smart, it means we are going to use the AI, which can detect on its own and understand that what is the SOH and SOC of the battery right now. What is the aging time of the battery? That can be also done. That can also be found if I am using the AI. Then autonomous and connected EV system, right? In order to perceive whatever is coming from the EV, that can be done properly when we are using the AI, right? We can use we can use machine learning and the reinforcement learning in order to make the decisions that when to put a brake, how to put a brake, what amount of the pressure has to be put on the brake so that no accident occurs. So different types of machine learning, or you can say reinforcement learning, can be placed so that our system or the EV system becomes autonomous as well as connected, right? So we need to have an intelligent charging and energy management, right? Right now, whatever the charging stations we are having, they are all very much clustered because we have a limited number of them, right? So we need to have the charging stations to be intelligent, in the sense they should understand what is the peak time and what is the normal time. So based on the peak time, the high load has to be collected from the transformer and should be given to the station, so that the transformer should not be loaded too much. Or if based on the user, it should understand that there is a more requirement of the transformer, or the connectivity, or the amount of electricity given to the particular station or particular location should be high or low, right? So that the whole management system related to the grid should be intelligent, right? Along with that, when we are going to the predictive operation, when we are performing the maintenance and all, then also we can use the AI. Business and research opportunities also there. Like we can go with the analytics of the EV, that how many electric vehicles can be brought in the future. So the data analytics and business analytics can also be brought, right? Yeah.
These are applicable for driverless or
for both of them, right? For both. Because if the EV, we are not saying only for the driver or driver. The data, if you are collecting, it can be used for any of them, right? So we can use AI in any case. If it is a driverless also, then also we are collecting the data from the sensors or from the cameras, which is let's say based on the back end or the front or on the sides, right? So based on that, we can also find that how many number of the cars should be, so what should be the minimum distance, right? So that there should not be any accident, or even it's just related to the, now it seems to be the for the driver. For the driver, if we can use that, what would be the best navigation system which we can use it, right? Which paths to follow, right? So all those things can come from both of them. Wherever needed, wherever it can classify or protect, then it can come to any of these. Now, coming into the deep learning, right? So this is the most important part. Like when I said machine learning or reinforcement learning or NP. Then there are the basic like linear regression when I said, or K-means when I said, or let's say we talked about decision tree, right, involvement. So all these are all shallow algorithms. They are not going into the details or the features of the data which is being bought from those devices or from those systems, right? So what it says is there are few features which need to be dealt in a very detail or very deep, right? So that's why we need to have a deep learning algorithm. So which extracts the feature from the data, right? So basically in the deep learning what happens that deep learning has started from this multi-layer perceptron neural network, simple neural network. Then moving into the several number of hidden layers, it has brought in the concept of deep learning. So I'll talk about this neural network a little bit in detail. So what does the deep learning do? It extracts the feature from the depth about the particular any of the data, whether it is a time series data or whether it is a simple image data, any type of data it is having. Okay. So the multi-layer representation is there in the deep learning, right? And the best part is that deep learning are able to extract the feature from both linear, non-linear, and complex data. Right? The simple data, when we are having it is, we can use the linear regression. But when it comes to complex data, non-linear pattern is there. Then how will, then the basic or you can say the traditional machine learning algorithms are not able to respond very well. Right? So in that case, we should be having this deep learning algorithm. So deep learning are able to capture the temporal as well as the spatial and the multivariate information which we are collecting from the EVs. They are able to sometimes, they are mostly able to outperform the conventional ML algorithms like I said, decision tree, regression tree, or maybe the linear regression and the multivariate. So this is just the evolution of deep learning algorithm, right? So we started with the perceptron, which is the basic of the simple neural network. We move towards the back propagation neural network, which is ANN. Then in between we had other types of the algorithms like a support vector machine. In between, then in the 90s we got to know about the CNN, which is advanced version of the neural network, that is convolution neural network. Later on, there have been so many improvements which is done on the CNN, for example, LeanNet, BGNet, GoogleNet, ResNet, and even YOLO. These are all the improvements which has been done on the CNN. Okay. So the deep learning concept has started basically from the perceptron. So why do we need to have a deep learning for the electric mobility, for any EVs or any devices, right? So the first thing is battery degradation and the electrothermal mechanics are non-linear. Whatever the data we are collecting, they are mostly non-linear. So we need to have a such model which should be good for the non-linear data along with the complex data. Right? When we are having data like motor torque, speed relationship varying to the load, temperature and inverter switching, all these data are coming, then also it is going to be complex. When we have autonomous driving requirement, then the real-time perception is there. The real-time images are coming from the cameras, right? And we are having several other sensors. So all those data which is now categorical data. Image data is also coming, real data is also coming. So how we are going to handle such data? So in that case, the deep learning model works very well. Okay. For the smart grids with the integration, when we are requiring the highly accurate when we require that the smart grids that we have for the EV, when we are integrating the EVs with the other models or other temporal models which are available there, when we are integrating them, and that time also we need to get the data which is going to be very complex. Mostly these deep learning algorithms, they work on the data and their data has to be, if the data is complex, then we should go with the deep learning. If it is simple data, there is no non-linear combination or complexity, then we can go with the simple data. Right? Simple algorithms, like simple machine learning algorithms. But when it starts with the complexity, missing data or with the invariation in the data, then we should start working with the deep learning models. So the first model which I am going to discuss is the neural network. There are several neural network architecture, but the first which I am going to discuss is multi-layer perceptron. So what is perceptron? Actually, if you see from the timeline, so the perceptron is the first model which has started talking about the deep learning. So what happens in the perceptron? in the case of perceptron, what happens? A perceptron is very similar to our human brain. It works on the basis of the biological nervous system. So it says that in our biological nervous system, we have small units or small elements. We call it as neuron. So based on the same concept, the artificial neural network has been created, and we are assuming that we are having a very small node. I'll use a very small element called this. Let's say this is called as a node or a neural network unit, right? So in our human brain, there are several number of the elements, or several number of the neurons which is there, right? It's more than a millions, trillions of the number of the neurons. But when we want to make, since we are becoming intelligent or we are intelligent because our neurons are there who are learning every time. What we want is that the machine should also have a similar architecture, something similar to the human brain. But it's not possible to do it's not possible to create trillions or millions of the neurons for the machine. So what they started is, they started with a simple unit, naming it as a node or a neuron, and saying that this is a one perceptron. So one node is the one which is taking the information from several nodes, because we know that every neuron inside our brain, they are connected with each other somehow. So that's why we are able to recall the previous thing which has happened, or whatever we have learned 20 years back also, we are able to recall it, right? Because there is always a connection between the neurons, and these connections help us recall the things, right? So the same concept they started into the perceptron, saying that let's assume that we are having one single unit named node, and now that node is connected, that neuron is connected with several other neurons, right? Now when there is a connection, there has to be some weight, right? So we are assuming that whenever there is any connection, there is going to be some weight value assigned to it, right? So let's say there is one node here, there is another node 2, there is another node 3 and 4. I'm assuming 4 nodes are there which is connected to this one single neuron. So when the connection is there, there has to be a weight value, so I'm calling this as a, let's say, 5. So this is W1 5, saying that there is a weight connection between the first and the fifth node. Similarly, W2 5, W3 5 and W4 5, saying that there is a connection between these two nodes with some value. So now what are these weight values? It could be any value between the range of, let's say, -1 to 1, -5 to +5, or -1 to -0.5 to +0.5, right? Most of the time it is used as a -1 to +1, right? So any value between -1 to +1 will be given in this way, right? If the positive value is positive, it is called as an excitatory neuron, saying that because of that, whatever the output will be generated here, it will be positive because it's a plus value, right? So if it is positive, the summation which is going to come here, it is going to be bigger. If it is negative, the summation is going to be less. So if there is a weight is positive, we call it as its excitatory. If it is negative, it is inhibitor. It is going to lower the summation value here. So what it says is, what is the output which will be coming here? Output is something that in the case of our biological nervous system, it says that the neuron has to fire something, has to trigger something so that some response should go to some another neuron. So that firing is something, a signal which is being generated. So here when we are talking in the occurrence of artificial, then it's not a signal, some value will be generated. So we say that the output Y will be there, which will be the summation of Wi, now J into X I am writing, I equals to 1 to X. So what is here? It says that whatever the weight connections are there with respect to their input, X1, X2, X3, X4, because there are 4 neurons, so definitely there should be some input coming to it. So input multiplied by weight plus input multiplied by weight, sum all of those values, whatever the final result comes up, that will be my final output, right? So now the output is the one which is deciding that whether it is going to be a regression based or it is going to be a classification based. Let's say I got the output over here is, let's say, 0.7, right? Now if it is a regression, I can directly say this is the exact value which I was looking for, right? If it is a classification, now I have to use some activation function to decide. So there are different types of activation function. For example, sign function, step function, read function, right? So let's say if I have a problem which is 2-class problem, saying that whether my pattern is faulty or not faulty, right? So I will say that this output which I got 0.7, I will compare with, I will use my, let's say, step function, saying that if my value is positive, my output is going to be 0. If value is negative, my output will be 1. So this is class 1, this is class 0, this is class 1. So if my output comes as a 0, I will say that my battery is faulty. If my output comes as a 1, I will say that my battery is not faulty at all. So this is the classification we are doing. So we used a simple perceptron to identify whether the battery is going to be faulty right now or not. Similarly, there could be other problems in your research. You can find it out where the classification is being done. So this is binary classification, saying that whether it is faulty or not faulty. There are other classification approach too. For example, support vector machine and all. Even the neural network also can be used to classify into several categories. For example, it is normal, it is faulty, it is not faulty. Right? So let's say if I want to go with three classes, right? So again we can use this whole data, this 0.7 which I am getting. I can say that if the value is greater than 0. Whatever the value comes, if it is greater than 0.3, it will belong to class 0. If the value lies between 0.3 to 0.7, it will belong to class 1. Similarly, if the value is greater than 0.1 but less than 0.7, right? Then in that case it belongs to class 3. Now the same result can be used for the multi-class classification also. Now you are the one who are putting the condition on how to classify, right? But you have to find out the problem from your end, that you need to understand whether it is going to be simple binary classification or it is going to be multi-class classification. So in the case of perceptron, what we did is we have calculated the output on the basis of multiplying the input with respect to the weights. Once we have the output, we are now deciding whether it is going to be the regression or the classification based on the problem. Now there is one major issue to understand. How will I get to know that how many number of input nodes will be there, right? So now let's go back to the previous example where I showed you example of supervised learning, right? So I showed you a data with the two features, right? And based on that, you are predicting the SOH percentage of the battery, right? So there are two data. Let's say I'm saying it as a X1 and X2 now, right? I'm comfortable. If everybody is comfortable, then I can calculate. Okay? So X1 and X2 are the two inputs. If you remember, the previous diagram was there. X1, X2, and then the percent, we were calculating the SOH percentage, right? So now you see how we will decide that how many input parameters are there, the number of the columns that we are, or number of the input features that we have taken. So we have taken two input features, means two number of the input should be taken. So by now the architecture will change with something like this. X1, X2, right? And then I'm generating the output, which is Y, based on these. So let's say this row number is 3, so my input rate will be now W13, W23. Similarly, if I'm considering any other example with 10 features, so how many number of the input neurons will be there? 10 input neurons will be there. Based on that, I will generate the output, right? So understanding that how many number of the input neurons will be there, or how many input neurons will be there, is based on how many number of the features we are having in our data, right? Now this is a simple perceptron. Now the perceptron has been moved, has been improved, and we have went into the multi-layer perceptron. The one drawback of this perceptron was there, it was not able to solve the non-linear problems. For example, XOR. Like AND and all, it was able to solve it. But when it went to XOR problem, this simple perceptron, it was not able to solve it. So for me, we moved toward this multi-layer perceptron. So what it says is, we are not going to have only the input layer and the output layer. You see, this is input layer, we were passing the input layer, and we are generating the output layer. So this is input layer, right? And this one is the output layer. But now it says that since we are not able to solve the non-linear problems like XOR, so we should move towards the multi-layer perceptron. So what it says is, okay, we can have a multi-layer perceptron. It says that we will not have only the input layer, but we will have the hidden layer too, and then we will have an output layer. So this is the input layer. Then we have a concept of a hidden layer here. Then we have a concept of the output layer. These two layers were already there. We had integrated one more there, which is a hidden layer. Now you see the connection is still going to be same. All of the nodes will be connected with each other, but only in a forward direction. right? All nodes are connected together, but in the forward direction. Now this will be connected in the forward direction. So my inputs are going to come here. So if I consider my data with the 3 input parameters, so my 3 input are going to be x1, x2, and x3, right? 3 inputs. Now based on that, some output will be generated here. Whatever the output, the output will be generated in the hidden layer. Now whatever the output comes in the hidden layer, that becomes the input for the next layer. Now we will calculate the output over here, right? So for this same thing, there is the architecture in the next page. You can see this. So this is the input layer now, hidden layer, and the output layer. This is a multi-layer perceptron. So what it says is, in the previous one we were not able to extract the deep details of the data because they were simple data and we were not required. But when we are passing the non-linear problem, it was not able to solve. Now because of this hidden layer, it will extract the hidden features also, right? Hidden features of the data. So the input layer is there, which will take all the input data. So if I am having 2 number of the input, the 2 input neurons will be there. If there are n number of the input parameters, n number of the input neurons will be there. Now there are a number of the hidden neurons. Even there could be several number of hidden layers also. You have to decide that how many number of hidden layers you want to create. There is no such research paper which says that this many number of hidden layers is sufficient or this many number of the hidden neuron is sufficient for your particular problem, right? So you have to decide that how many number of the hidden layers you want to create. So this is right now 1 hidden layer, so we call it as a 2-layer. We call it as a 2-layer multi-layer perceptron. If there is a 3-layer, means one more hidden layer is there, then it could be called as a 3-layer neural network or 3-layer multi-layer perceptron. So in every layer itself, you have to also decide that how many number of the hidden neurons should be there. So hidden neuron is also defined by the programmer or by the user. You have to understand that how many is working for you. Maybe for my particular problem, 10 neuron, 10 in a 1 hidden layer is working. Maybe for your problem, it is not going to work. So you have to go through this hidden trial method to understand that how many number of neurons will work for you, how many number of the hidden layers will work for you, and along with that, it is also not mandatory that all the hidden layers should have the same number of the hidden neurons. Okay. Now, based on that, now we are calculating the output here, right? So it's very similar to the previous one. There is one thing which I said earlier, that we use the activation function, right? So in the previous, when I was explaining, I used here activation function as a step function, right? Now here we have used another activation function, which is called as a sigmoid activation function. So I hope everybody is aware of the equation 1 upon 1 plus e to the power minus 6. So the sigmoid is 1 upon 1 plus e to the power minus of x. So this portion is actually nothing. It's just calculating 1 upon 1 plus e to the power minus 6. Instead of the minus ones, right, so you have calculated the whole output. So I wrote earlier this wij into xi. There is one more term which is called as bias, which is not mentioned here also. So there is another term which is placed as a bias, right? So there is one more connection to all the neurons in the hidden layer and the output layer. So that's why we added one. So if you see, let's say I want to calculate output on this particular neuron. So whatever the weight connection is there multiplied by their input. So let's say the first one, so the x1 multiplied by whatever is the weight here, plus x2 multiplied by whatever is the weight here. So total sum. Plus there is another element, one more connection which is called as a bias. So this will be also added. So I can write wij into xi plus of whatever the bias is there. So let's say I'm calling it as a bj. Okay. See, this is the same thing. Now we are putting into the activation function. So 1 upon 1 plus e to the power whole function. Now this is the same equation. Now this is for one particular neuron. Now if I want to calculate what is the output on this neuron, so it should be the summation of whatever the output came here will now become the input for this one. Whatever the output we got here will become the input again for this one. So summation of all the inputs here, weight into the inputs will now give the result for this one. So this is the same thing. It's saying that if I want to calculate the output on the yk, means y2, let's say, then we will get then we have to put into this equation. If I want to calculate the output on this one, y1, then we will change the k to 1 and I will get the output here, right? So the same approach will be applied. Whatever we are applying here will be applied for several number of the multi-layer perceptron also. If we are having more than one layer, the same equation will be applied. The equation is not going to change. The only thing what we are doing is we are always moving in a forward direction to calculate what is the output going to be. So here again we can do the regression as well as classification, means prediction and the classification as per your problem.
BK.
BK is the bias, which B is the bias term, which I said. This is the bias will be added to each and every neuron which is there in the hidden layer and the output layer. So these are the extra weights which we are assigning, right? But it is not the weight which is coming from the neuron. This is something extra which we are providing. It's like I can give an example. In the chemistry might be that we need to provide some extra energy so that they can move from one state to another state, right? So it's like we are providing extra bias, stating that whatever the output comes up, it should be excited, it should excite, it should not become zero, it should be some output. So we are providing some extra term here, that value will be added with all the weights, whatever the result was coming earlier, plus this value also some. Right? So we had this equation earlier, I added this one more extra variable to it. Right? So because of that, whatever the, now this we call it as nothing as a bias, this term is just a bias, which is for all the hidden neurons and all the output neurons. Right? Based on that we calculate the output. BK is the bias on the K. This is K number of the output neurons are there. So what if I am talking about this second neuron, second output neuron, so this is B2. K number of output neurons are there, J number of hidden neurons are there, and I number of input neurons are there. Okay, I, J, K for input, number of input neurons, number of hidden neurons, and number of output neurons.
So we will break for T before we move on next topic. Okay? We'll have break for T.